Hello everyone, welcome back to freepilotgroundschool.ca. This is our 11th lesson in air law on the subject matter, air traffic services and procedures. And although air law is a very dry, pretty boring subject for most people, we're past the halfway point now. I promise you things are going to get easier, less tedious, and more practical now. And this lesson is quite important because we will be dealing with air traffic services as pilots regularly, and there's procedures that need to be followed as pilots. So let's get started. Few definitions to get started here. An airport control service is provided by a control tower for aircraft and vehicles operating at or in the vicinity of an aerodrome. An area control service is provided by area control centers to instrument flight rules, IFR and VFR traffic within a control area. So this might cover, let's say we have Winnipeg Center and they cover all the high level airspace, category or the Class A airspace between, let's say, Sault Ste. Marie all the way to the, let's say, Regina and north. Flight information service assists pilots by supplying information about known hazardous flight conditions, and an automated terminal information service is a pre-recorded message with weather, active runway, and applicable NOTAMs. Primary goal is to reduce frequency congestion. You just have to get all the information of the weather. You just tune up that frequency, listen to it, write it down, and then when you actually call tower, they do not need to repeat it for you. There are these different control services go by different suffixes. It usually starts with the city they're located in and then followed by the appropriate suffix. So for example, we say Prince George Tower or Prince George Ground. That's the tower control and ground control respectively. Area Control Center, Winnipeg Center, we'd call them. A flight information service is also called Winnipeg Center, and a flight service station is called radio. So for example, Timmins Radio. Modern technology is a wonderful thing. A lot of air traffic control have radar services. In fact, pretty much they all do these days. There are two different kinds of radar services, primary radar and secondary radar. Primary radar just shows the position of an object. Basically the same technologies, what came out during the Second World War. It's just a sweep, and as you can see here, it's kind of a little cartoon or graphic. But not only aircraft will show up, sometimes you'll have large flocks of geese show up as well. Sometimes rain, thunderstorms will show up on this radar. And then we have secondary radar, and secondary radar gets a signal from the aircraft transponder. It displays the aircraft identification, position, altitude, and speed. So on the right here, you see this congested radar display, all these aircraft coming into land, looks like in Toronto, and we'll just take a closer look here. If we take a look, we have the identification, the squawk code, and the altitude and airspeed, or sorry, not airspeed, ground speed. Well, air traffic control often provides traffic information using what's called the clock system. 12 o'clock is straight ahead, 3 o'clock is 90 degrees to the right side. So for example, air traffic control might say, Fox Alpha Bravo Charlie, traffic information, Cessna 180, 2 o'clock, 3,000 feet heading northbound. Should be pretty obvious. You have traffic out about 60 degrees off your nose, and they're at 3,000 feet, and they're heading north. Now you know where to look. Now, even though that air traffic control might give you radar service and give you traffic service, it's imperative that you know that this radar service does not relieve the pilot of traffic separation responsibilities when VFR. It's a big sky, they're small airplanes, and that's the principle of collision avoidance. And the fact that you should be looking outside, making sure that you are not going to hit other traffic. Now, we talked about these secondary radar. They use something called a transponder. The transponder, you can put a code as assigned by air traffic control. It's a 4-digit code. But these codes are called squawk codes. The standard VFR squawk code, you put 1200, and if you're above 12,500 feet, you put 1400 in the squawk code. But when you're talking to air traffic control, they'll usually give you what's called a discrete squawk code. So they might say Alpha Bravo Charlie squawk 4474. Then you're going to select 4474, the digits in your transponder. There's also a feature on your transponder called the ident feature, identification. What this does is you press that button and it makes that target flash on ATC radar. So when you're in a busy area with lots of traffic, they don't know who you are or where you are. They might tell you squawk ident. You push the button and it flashes, and then it confirms to them who you are and where you are, and they can readily find you on their big radar screen. And because of this, you only want to press the ident button when directed by air traffic control, because they want to see only one aircraft's transponder replying and flashing to them. Let's talk about ATC clearances and instructions. And these are very important that you understand the difference. An instruction is a directive issued by ATC that must be complied with as long as flight safety is not jeopardized. You must read air traffic control instructions back. So an example is air traffic control might say, maintain runway heading to 4,000, in which case you would respond, runway heading to 4,000, Alpha Bravo Charlie, whatever your identification is. Okay. An emphasis, though, is that flight safety is not jeopardized. You have every right not to comply with an air traffic control instruction or a clearance when flight safety is jeopardized. So just an example, I was flying, doing some training in a light single engine aircraft, practicing some instrument approaches at night. And on the departure end of the runway is, well, I'm not going to say it's a mountain because that would kind of be insulting to mountains for people from like BC, but I am in Ontario, so it's a bigger than a hill, smaller than a mountain. It's about 1,000 feet above airport elevation, and it's about 4 miles, 3 to 4 miles off the departure end of one runway. So we were doing instrument approaches, and air traffic control said to me, whatever the registration was, on departure, maintain runway heading to 4,000 feet. And I responded, unable runway heading due to the mountain and the fact that it's night. I'd like to make a left turn heading whatever heading I asked for 3,000 feet. Now, if it was during the day, no big deal. I can see this mountain and I'm probably going to clear it. But I'm not really going to fly towards a big hill at night in a single engine airplane when there's a chance that I'm not going to see something before I can avoid it. So always flight safety and common sense will prevail. The next thing that we have is an ATC clearance. So difference from a clearance and an instruction, the clearance obviously tells you that you're cleared to do something or you're authorized to proceed. It always will contain the word clear. And the expectation by ATC is that you will proceed with the clearance once you accept it. So an example is clear for takeoff, clear to land. Once you acknowledge it, they're expecting you to do it, of course, commensurate with flight safety. In aircraft, especially large aircraft, we have something called wake turbulence, which we'll learn considerably more about during your flight operations lessons and your theory of flight lessons. These are caused by wingtip vortices. We can make a rough analogy that they are similar to the wake behind a boat, but they are most prevalent in heavy aircraft when they are taking off. They can very easily in a large aircraft flip another aircraft over. This has happened. Light aircraft takes off behind a medium or heavy aircraft and it just flips the plane right over. That plane crashes into the ground. And because of this, air traffic control gives wake turbulence separation, a certain distance behind another aircraft. But regardless of this, wake turbulence separation is always the responsibility of the pilot. And so maybe you've picked up a pattern here. Everything is your responsibility as a pilot. However, air traffic control will help you out. And here are some distances that they give you. So a light aircraft behind a medium, they will give, let's just say 4 miles. We can see that at the bottom here, whereas a medium behind a super heavy, so that would be something like a 737 behind Airbus A380. That's 7 miles right there. So let's talk about some controlled and uncontrolled airport operations. So let's begin with controlled airports. We're going to cover a bit more of this in radio communications, and you will learn some more of this when you study towards your radio license. So we want to go somewhere and we're sitting on the ramp, the engine's running. Let's say we've done our run up, we've completed our checklist. We are now ready to taxi to the runway for takeoff. The first thing that we do is we start with an initial call. We're going to make a call such as Winnipeg ground. This is Cessna 180, Foxtrot Alpha Bravo Charlie with information echo. So who we're calling, who we are, and the ATIS information that we talked about earlier in this lesson, which is denoted by a phonetic alphabet identifier. Okay, they will respond, and pretty much the way you make every radio call is who you are, and where you're going or what you want to do. So in this case, they would respond, they would say, Alpha Bravo Charlie, this is Winnipeg ground, go ahead. And you're going to then make your call. Alpha Bravo Charlie, on apron 4, request taxi clearance for VFR flight to Moosonee at 7,500 feet. So in this case, our identifier, where we are, which is apron 4, and what we want to do. We want taxi clearance for a VFR flight to Moosonee at 7,500 feet. At that point, they will come back and give you a taxi clearance, such as saying Alpha Bravo Charlie, taxi Alpha Bravo, hold short runway 36. Something along that line. They might give you a squawk code. They might ask a clarifying question or something like that. However, when you get this clearance, once you get it, you have to comply with it and taxi as directed. When you're on a ground in a controlled airport, all aircraft require taxi clearance. And typically, air traffic control will tell you to hold short of a runway. There are typically markings indicating where you need to hold short, but if there are no markings, you need to hold short 200 feet from the edge of the runway. Let's say now we've taxied to our runway, runway 36. We're going to switch over to the tower frequency. We're going to say Winnipeg Tower, Foxtrot Alpha Bravo Charlie, holding short, runway 36, ready for departure. So again, same formula, who we are, where we are, what we want to do. So who we are, Fox Alpha Bravo Charlie, where we are, we're holding short runway 36, and what we want to do, well, we're ready for departure. So that pretty much means please give us takeoff clearance. Pilots do not require permission from tower to switch frequency once clear of the zone, but it is a courtesy. Okay, now let's say we're arriving at an airport that is controlled. We have to call prior to entering the control zone. We can see, like we studied earlier, where these control zones are by looking at a map. But the courtesy is that we're going to call 5 to 15 miles ahead, depending on the speed. An aircraft that's traveling at 250 knots, give them plenty of time. Let them know you're coming, as opposed to announcing when you're 5 miles out, oh, here I am, I'm going to be over your airport in basically a minute or two. Again, the radio call follows the same standard sequence. We're going to make an initial radio call. Winnipeg Tower, this is Cessna 180, Fox Alpha Bravo Charlie with information echo. So what this allows them to do is kind of write down the information, process that somebody's coming in, kind of get ready for your call. They're going to respond, go ahead. You're going to say Alpha Bravo Charlie, 10 miles north at 4,000 feet, inbound for landing, last departed Baker Lake. So again, who we are, Alpha Bravo Charlie, where we are, 10 miles north at 4,000 feet, what we want to do, we're inbound for landing. And then when you're from another airport, they also want to know where you departed. At a controlled airport or a mandatory frequency, you can join the circuit anywhere as indicated by ATC. They might say you're cleared straight in approach. They might say left base, join the downwind, anything they want to do. A standard circuit is a left-hand circuit, meaning all turns are left-hand. The turn after departure to crosswind is left-hand, onto downwind is left-hand, onto base is left-hand, and then of course the final is left-hand as well. Now let's talk about a communications failure. And the overarching guidance for a communications failure is don't do anything that ATC would not expect. So don't do something like, oh, let's say you talk to ATC, you're on short final, you have a communications failure, and now all of a sudden you decide to do a go around and go to another airport, and they go, where in the world did that airplane just go? We have no idea what they're doing. So let's say you're on short final and you have a communications failure. Well, just land and give them a call afterwards. They're usually quite understanding. Having said that, can you guess what the biggest reason for communications failure is? Well, unfortunately, it's pilots screwing something up on the radio, pushing the wrong button, talking on the wrong radio, doing something like that. However, if you do have a communications failure, there is a standard squawk code. Remember your transponder that we just talked about? That code is 7600, 7600. If you are coming in to land, and you've already talked to air traffic control, what you're going to do is just follow their latest instruction and wait for light signals. If you haven't talked to them, you fly overhead the airport, probably about 1,500 or 2,000 feet, and just circle the control tower for a bit, and they'll probably give you light signals, at which time you can join the circuit and land. Here are these light signals, and you do need to memorize these because they will be on some sort of test or exam. But there is a way to make these easier. So if you think of a certain order, in order of, let's just say, importance, the order of importance from lowest, or let's say gravity, the order of how, gravity is at the bottom. We have something that you absolutely cannot do is a flashing red light. After that is a flashing, or is a solid red light. The next thing above that is a flashing green light, followed by a solid green light. So just think about that order, and then that will help you kind of think what they want me to do. So let's just talk about the worst thing, a flashing red light, and we're on the ground. That means taxi clear of landing area in use. That's bad. Like, get off the runway, hurry up. Okay. Now the next one up is a steady red light. Well, that means stop. So it's not quite as serious as a flashing red light. After that, we have flashing green lights. That would be clear for taxi. So it's kind of a step up. And then a steady green light is clear for takeoff. So that is the other end of the scale, what's kind of the most important. If you have a flashing white light, return at starting point, and blinking runway lights means get off the runway immediately. So it's pretty much the same as the flashing red lights, but it also is addressing pedestrians and vehicles. In flight, it's the same kind of principle. A flashing red light means airport unsafe, do not land. That's bad. A steady red light, give way to other aircraft and continue circling. A series of green flashes, return for landing. And a steady green light would be clear to land. So if we think how this would apply, let's just say we have a communications failure, we fly overhead the airfield, we circle the control tower, and I get a steady red light. So there's other aircraft in the circuit. I think this is pretty unlikely. They'd probably tell all those guys to leave and clear you to land. But they gave you a steady red light, so you continue circling. Then all of a sudden, they give you a green flashing light, return for landing. Okay, so I guess I'm joining the circuit. You join the circuit, and then they give you a steady green light on final approach, which means clear to land. Sometime during your training, probably before solo, your flight instructor will have air traffic control give you these light signals just so you know what they are like. Obviously, they're quite a bit brighter during the night than during the day, but if you're looking right at the control tower on final, it's very obvious that there's a bright green light shining at you. So we discussed this earlier in this lesson, as well as the previous lesson. At a controlled airport, so somewhere where there's a mandatory frequency, you can join the circuit anywhere as directed by air traffic control. If they say cleared left base, well, you're just going to come here and come in and land. They might say straight in, going to come in. They might say join a downwind. You can join here, or you can join here at an angle, or they say join cross overhead the field. You come up here, you join the downwind. Whatever air traffic control tells you to do. Now let's talk about uncontrolled airport operations, or more specifically, airports that have an aerodrome traffic frequency. So there might be airplanes there that are not talking on the radio. They don't need to talk on the radio. It's not required. They might be ultralights. They might not be equipped with a radio. So no air traffic control exists, and it's up to pilots to avoid one another. At these airports, it's essential that pilots look out for other traffic. So here's what you're going to do. If you're not in the circuit, you don't know what the wind is like, for example, you're going to fly overhead the field 500 feet above circuit altitude. Then you're going to be at circuit altitude on the downwind, even if you cross overhead the field, and you always descend on the upwind side of the circuit. So here's an example. We're coming from this direction. This airfield is, let's say, 1,000 feet above sea level. I'm just going to fly towards the airport at 2,500 feet. So 1,000 feet above sea level. So the circuit height is 2,000 feet. Add 500 feet above that. It's 2,000 feet above sea level. I'm going to fly overhead the airport. I'm going to descend here down to 2,000 feet. So 1,000 feet above sea level, the circuit height. Come back, join overhead the field, join downwind, and final. The other thing I can do here is join a straight in downwind from right here if I know that this is the circuit. Obviously, if we're landing on the other runway, let's say going this way, I would cross overhead the field here at 2,000 feet and join the circuit and come in and land. It's important that you keep an eye out for other traffic, as well as make your proper radio calls, which we'll discuss later. At an uncontrolled airport with an aerodrome traffic frequency, radio calls are not required but highly suggested. You must join the circuit on the downwind side or overhead the field, as we just discussed. There are a number of radio calls that you should make prior to taking position on the runway, clear of the circuit on departure, overhead the field, downwind, final, and clear the runway. So let's say we're departing. We're here, we're going to come here position. We're going to make a radio call right here. Alpha Bravo Charlie, taxiing position, runway 27. And we now take off. And we fly away. We're now clear of the circuit. Alpha Bravo Charlie, clear the circuit. At that point, you can call another, change frequencies, go somewhere else. Then let's say we come back. Okay, we're on our way back. Going to make our radio call, overhead the field, on downwind, on final, and after we take off, we're clear of the runway. We're going to make another radio call. So here's kind of an important nuance that you need to know, but sometimes it's difficult for people to understand. All controlled airports have mandatory frequencies, and so these controlled procedures that we just discussed apply, but not all mandatory frequencies are controlled. Anytime there's an MF, they require radio and proper radio calls. Most uncontrolled airports have aerodrome traffic frequencies. However, some of them also have mandatory frequencies. If you have a mandatory frequency, you must have a radio. You must make the proper radio calls, but you are allowed to join the circuit anywhere you'd like. If it's an aerodrome traffic frequency, you can only join the circuit overhead the field or on the downwind. Let's take a look at this here. If we look at this map here of Thunder Bay, let's look at Martin's Landing right here. An airstrip of a friend of mine, Rick Martin. You can take a look here. The elevation is 1,114 feet above sea level. The length of the field, 2,100 feet. A122.8. Aerodrome traffic frequency is 122.8. If you fly into Martin's Landing, you must cross overhead the field or on a straight in downwind. Here's another one, Kakabeka Falls. It's 1,000 feet above sea level, 2,100 feet long. A123.0. It's an aerodrome traffic frequency. Again, you must join overhead the field or on a straight in downwind. Here we have Thunder Bay, and if I would have had this map on a kind of a bigger scale, you would see that it says M118.1, mandatory frequency, tower frequency 118.1. Here's an example of an airport that is uncontrolled but has an MF, a mandatory frequency, Atacocan. The elevation is 1,409 feet. L, this is lighting. The runway is 3,500 feet. And M, 122.3. So it's uncontrolled, but has a mandatory frequency. The frequency you need to be on, 122.3. So try to think back what you're allowed doing. Are you allowed going straight in final? Yes, you are. Even though it's uncontrolled, there's a mandatory frequency, and everyone that's flying there will have a radio, or at least they should have a radio. Let's talk about these required radio calls. You have to make a radio call prior to entering the maneuvering area, so a taxiway or runway, prior to entering the runway, and if you're delayed on the runway, departing the circuit, 5 minutes prior to joining the circuit and or downwind, final approach and clear of the runway. The standard ATF frequencies are 122.8 or 123.0. You should memorize these. However, if there's no frequency specified, the frequency is 123.2. Okay, now we have departed whatever airport and we're en route somewhere. The frequency you're going to monitor is 126.7. If you have a second radio, you're going to monitor the emergency frequency as well, 121.5, just in case there are aircraft in distress. Periodically, you may want to make position reports. These position reports are so that other aircraft in the area know where you are and where you're going, and will keep an eye out for you and remain clear of your area. The standard radio call, just like earlier, who you are, where you are, and what you're doing. So the registration, position, altitude, and intentions. For example, you would say, Foxtrot Alpha Bravo Charlie, 10 miles west of Red Lake at 4,500 feet, overflying Red Lake en route to Oak Lake. People will know, okay, this is where they are, 10 miles west of Red Lake, this altitude, and what you're doing. Sometimes you might be flying and into a controlled airport, and air traffic control may ask you to hold over a VFR landmark. Okay, this might be something that's commonly known. Sometimes there are, let's say, large smokestacks or a bridge or something like that. They might ask you to do this because there's too much traffic or emergency, and they will say something like, Alpha Bravo Charlie, remain clear of the control zone. Hold over the large smokestack at 3,500 feet. Remain VFR. At large, busy airports, there may be intersecting runways, and air traffic control will be utilizing both of them. Realistically, you won't be doing this too often as a private pilot because most airports that are big enough will have parallel runways or they'll just slow things down. An example, though, of an airport that uses a lot of intersecting runways is LaGuardia. And often what they will ask you to do is they will land and hold short of an intersecting runway. They do this so that they can have another aircraft take off on that intersecting runway. You must, in that case, land and hold short of that runway. So think of it as simply a shorter runway. Also, sometimes you might be taking off from an intersecting runway, from a runway intersection. In this case, air traffic control will provide the runway length remaining. However, it is still the pilot and command's responsibility to ensure that they have sufficient runway length to safely take off. Unfortunately, one of the leading causes of accidents is runway incursions. This is when an aircraft taxis onto a runway that they weren't clear to taxi on, and unfortunately an aircraft is landing at that time. So operating on the ground that I have found flying large commercial aircraft is by far the most difficult part of the job. Landing is relatively easy. Trying to follow a taxi clearance in a place like San Francisco or LaGuardia, when there's so much traffic and so much opportunity for error, is by far the most difficult. And so there are a number of things that you can do to prevent runway incursion. One, you must read back all hold short instructions. If they say Alpha Bravo Charlie, hold short runway 31, you say hold short 31, Alpha Bravo Charlie. When you cross or enter runways, you take a very good look out to the left side and to the right side. Think of it similar to the way a school bus driver, they stop at train tracks. Now, you shouldn't be stopping because you'll hold up traffic, but take a really good look out. Also on the ground, it's important to have a sterile cockpit. Don't talk. It's time to pay attention and live up to the task at hand as opposed to chatting about whatever thing is on your mind. Okay, let's start our review of this subject. Remember that radar service does not relieve a pilot of traffic separation. The standard transponder squawk codes are 1200 and 1400 for above 12,500 feet. The transponder feature makes your target flash on ATC radar. Only push it when directed by ATC. And ATC uses a clock system to provide traffic information. An instruction is a directive issued by ATC that must be complied with as long as flight safety is not jeopardized. A clearance is an authorization by ATC to proceed with something, such as a landing or a takeoff. At a controlled airport, you need a clearance for everything, but you can join the circuit as cleared. You must contact ATC prior to joining a circuit. At an uncontrolled airport, you join the circuit overhead or downwind. All controlled airports have mandatory frequencies. Some uncontrolled airports have mandatory frequencies, but most have air-drone traffic frequencies. When you're en route, you want to monitor 126.7 or the emergency frequency 121.5. Okay, now it's time to start these sample test questions. I've got a lot of these for you that we're going to go through because, well, they're like I told you earlier, there's a heavy emphasis on this subject on both your P-STAR as well as your private pilot license written exam. So the first question, a series of green flashes directed to an aircraft means respectively in flight or on the ground. So let's go through it. In flight, green flashes, that's return for landing. Remember, clear to land is a steady green light. On the ground, it is clear for taxi. The steady green light is a clear for takeoff. So the correct answer, C, return for landing, clear to taxi. A steady red light directed at an aircraft means in flight and on the ground. So remember, a steady red light is not as bad as a flashing red light. So in flight means give way to other aircraft, and on the ground, it is stop. A flashing red light would mean do not land or taxi clear of landing area in use. So the correct answer, A, give way to other aircraft and continue circling, and stop. So we just discussed this. A series of red flashing lights directed at an aircraft means respectively in flight and on the ground. So this is the worst thing. So in flight, the worst thing is airport unsafe, do not land. And on the ground, taxi clear of landing area in use. Remember, the steady green light is to continue circling or stop. So the correct answer, A, airport unsafe, do not land, and taxi clear of landing area in use. Here's one with green lights. A steady green light directed at an aircraft means respectively in flight, on the ground. So remember, a steady green light is the best thing that can happen. So in flight, it's going to be clear to land, and on the ground, it's going to be clear for takeoff. So the correct answer is going to be D, clear to land and clear to takeoff. Here's an obscure one. A flashing white light directed to an aircraft on the maneuvering of an airport means, well, this one, unfortunately, well, we can go process of elimination. So is it A, stop? No, because that would be a solid red light. Return a starting point? That sounds about right. Clear for taxi? No, because that would be a flashing green light. Taxi clear of landing area in use? No, that would be a flashing red light. So the correct answer, B, return to starting point on the airport. Here's another one that we can figure out just by using some common sense. Blinking runway lights advises vehicles and pedestrians too. Well, just think about it. You're driving your quad down the runway and there's blinking runway lights. What do you think that means? Well, let's just say it's vacate the runways immediately. Here's a question that will come up both on your P-STAR as well as something similar on your radio license. On initial contact with a Canadian ATC unit, the pilot of aircraft CGFLU should transmit the registration as. So remember, the registration is the last 4 letters. So Golf, Foxtrot, Lima, Uniform. C is the correct answer. They also have over in here, which is technically correct, but nobody ever really uses that anymore. So after you've made your initial call, what can be dropped? So after Canadian privately registered aircraft has made initial contact with an ATS unit, which items may be omitted from subsequent transmission? The aircraft type and. So what can be omitted is you don't need to say your aircraft type anymore, and you can get rid of the first 2 letters of the registration if initiated by ATS. So all you need to do is say your last 3 letters. The correct answer, B, the first two letters of the registration. So let's say Charlie Golf, and only if it's initiated by air traffic services. On initial contact with ATS unit, the pilot shall transmit. So if you can recall, what do we transmit? Well, the aircraft type and the last four letters of the registration. So that would make A the correct answer. ATIS, or Automated Terminal Information Service, is normally provided. So if we recall back, I think, to the first slide or second slide, what it does, it tells you about the weather and tells you about significant NOTAMs. The purpose of it is to relieve frequency congestion, B. Where ATIS is available, the information which should be included on first contact with ATC is, so A, phrase with the numbers, B, phrase ATIS received, C, phrase with the information, D, ATIS phonetic identifier. So remember, we said that it's an identifier like letters A, B, C, and phonetics, Alpha, Bravo, Charlie. So information echo. So that's D, the ATIS phonetic identifier. Whenever practicable, pilots operating VFR en route and uncontrolled airspace should continuously monitor. So this one just kind of comes down to memory and probably which one is not like the other. So 123.2 and 122.8, if you recall, are the ATF frequencies. 122.2 is another kind of frequency similar. So the correct answer, 126.7. You can also get a hold of flight service on that frequency too. So en route aircraft should, whenever possible, maintain a listening watch for aircraft in distress on. So remember, whenever possible, that's if you have like a second radio. Your first choice will be 126.7. If you have a second radio, you're going to listen to the emergency frequency. So remember, what is the emergency frequency? It's 121.5. So let's go through these. The receiver mode of the ELT. Well, I've never really heard of the receiver mode. B, 121.5 on the aircraft receiver. Yeah, that sounds right. 121.5 during the first 5 minutes of every hour. No, you wouldn't do that. That's confusing that with something else that we'll talk about in a later lesson. And the voice frequency of the navigation aid in use. Well, that's not correct. So correct answer B, 121.5. Pilots operating a VMC and intending to land at an aerodrome where no Unicom exists should broadcast their intentions on the ATF of. So this is where there's no frequency published. And this just comes down to a basic memorization question, 123.2. But we can do some process of elimination. We know from 121.5's emergency, so it's not that. 122.2 could be that. 123.2, that's the right answer. 126.7 is the en route frequency. So it kind of comes down to those two, and well, the correct answer is 123.2. Pilots broadcasting on an MF where no ground station is in operation should direct their transmission to, well, process of elimination, aerodrome Unicom. No, there's no ground station. Closest ATC unit? No, there's no ground station. Aerodrome traffic. Well, that is the correct answer. Or first aircraft heard on the frequency. Well, you do need to make a radio call, and you're not going to wait until there's other traffic. So correct answer C, aerodrome traffic. So an example, Kekabeka Falls traffic. This is Alpha Bravo Charlie. If somebody responds and says, oh yeah, I'm in the circuit. Hey, here I am. Well, now you can call them directly. You can say, X-ray Yankee Zulu, it's Alpha Bravo Charlie. We're departing runway 24. They say, okay, check, we're on left downwind. We'll stay out of your way. If an MF is in use, pilots departing VFR shall monitor that frequency until A, beyond the specified distance or altitude, B, established en route, C, established at cruise altitude, or D, clear of the aerodrome circuit pattern. This is a really good question. It's actually kind of tricky. The correct answer actually is A, beyond the specified distance or altitude, because typically in an MF, there will be like a control zone or something like that, and you have to monitor that frequency until you're clear of the control zone. If you're in an ATF, it's clear of the aerodrome circuit pattern. So there is a difference there. Pilot is clear to taxi to the runway in use without a hold short clearance. To get there, the aircraft must cross 2 taxiways and 1 runway. This authorizes the pilot to taxi to. So A, the runway in use but must hold short. No, you have to get a clearance across every runway, so that's not correct. B, the runway in use but further clearance is required to cross each taxiway and runway en route. Well, no, you don't need further clearance to taxi a taxiway, so that's not correct. C, position on the runway with further clearance. No. And D, the runway in use but further clearance is required to cross the other runway. So that is correct, D. You can taxi to the runway, but you need clearance in order to cross each runway. So in this case, They might say Alpha Bravo Charlie cleared runway 36, taxi Alpha cross runway 31. That would kind of be an example that they might give you. Ground control authorizes Golf Alpha Bravo Charlie, taxi runway 29, hold short runway 04. The pilot should acknowledge this by replying Golf Alpha Bravo Charlie 2. And remember, we have to always read back hold short clearances. So hold short 04, D. Here's something that we didn't talk about, but it might come up on a test. When a clearance for an immediate takeoff is accepted, the pilot shall. An immediate takeoff means you don't stop. So usually they give you an immediate takeoff because there's traffic on final, but they're nice enough that they want to get you flying as opposed to waiting for that traffic, but they don't want you to take your time. So what you're going to do is you're going to taxi on the runway and take off in one continuous movement. You're not going to stop. You're not going to lollygag on the runway. Just get going. They're being nice to you. The question on the clock system. A pilot flying a heading of 270 receives the following message from ATC. Traffic 2 o'clock, 5 miles eastbound. This information indicates that the traffic is, well, 2 o'clock, each hour of a clock is 30 degrees. So 2 o'clock would be 60 degrees. And 2 o'clock is to the right. So 60 degrees to the right and altitude unknown, D. So here's a question that requires a bit of thinking. The pilot receives the following ATC clearance. Clear to land, turn right at the first intersection. The pilot should, well, land and attempt to turn off even though the speed is considered too high to safely accomplish a turn. Well, that's just stupid. I hope nobody answers that. B, complete a touch and go if it is not possible to safely accomplish the turn. Well, that seems like a rather silly thing to do. C, land and turn off at the nearest intersection possible commensurate with safety. Well, that sounds awfully common sense. And land and do a 180, turn back and taxi to the clearance at the runway at the required intersection. So again, no, don't do things with air traffic control that they're not expecting. Just do what ordinary common sense people would do, and most of the time you are going to be right. So correct answer C. Here's a question on transponders. Unless ATC instructs otherwise, pilots operating VFR shall select transponder code 12 when flying at or below blank feet ASL and code blank when flying above that altitude. So remember the altitude, 12,500 feet, and you should recall from your airspace. Remember, that's when Class B airspace starts, and above the altitude, it's 1,400. Correct answer, A. Pilots shall activate the transponder ident feature. So recall this is kind of a basic memory question. It's only when assigned instructed to do so by ATC, so B. Okay, here's a good example of a question. What's the most correct answer? And a bit of common sense. The PIC of an aircraft shall comply with any light signals or ground markings prescribed in the cars, only when in Class C airspace if they are part of an ATC clearance. Well, no, that doesn't sound right. Only while in a control zone if they're part of an ATC instruction. Well, again, that doesn't sound right either because there might be ground signals that telling you to hold short at all times. Well, that's probably pretty correct. Yeah, you have to follow light signals and ground markings at all times. But here's a more correct answer. At all times provided safety is not jeopardized. So that's kind of the overarching thing. You have to follow the rules, but if it jeopardizes safety, there are exceptions allowed. So D is the correct answer. Avoiding wake turbulence is, and recall, everything is the responsibility of the pilot in command. So correct answer D, the responsibility of the pilot in command. It is not air traffic control's responsibility, but they will provide you a warning. ATC advises that simultaneous operations are in progress at an airport. Pilots could be expected a clearance to A, take off over top of an aircraft on an intercepting runway. That sounds like a bad idea. No. B, take off on a specified parallel runway. Well, the simultaneous operations, remember, they're intersecting, so that's probably right. Land and hold short of an intersecting runway. Yeah, that sounds plausible. Or land on a specified parallel runway. Well, we already said they're intersecting, so C is the correct answer. Okay, our last question. We're almost done here, guys. When issued a clearance to land and hold short of an intersecting runway, pilots, A, shall comply regardless of the circumstances. Well, that's probably not a good idea. You want to comply, but circumstances always dictate what you do. B, may taxi across the intersection after the departing or arriving aircraft has cleared their path. No, remember, you always need a clearance to cross a runway from ATC. C, who would inadvertently go back to the intersection to immediately do a 180 turn and backtrack on to the hold position. That kind of goes to like, don't do anything that's going to scare air traffic control. Don't do that. D, should immediately inform ATC if they are unable to comply. That is the correct answer. If you can't do it, you just don't do it and you let ATC know. Okay, that's it for this lesson, guys. I know it's been long. It is an important one. Thanks so much for bearing with me as we work our way through it, and we'll see you on the next lesson. The next lessons are going to be considerably shorter. We're on the downhill stretch, maybe only an hour or two to go in air law. Thanks for your patience. We'll see you on the next lesson.